Hello everyone, and welcome to this new and exciting session in which we are going to treat TensorFlow record. TensorFlow records helps us build more efficient data pipelines as they help us store data which we are to use to train our models more efficiently, and also they help in parallelizing the reading of the data, hence helping in speeding up the overall training process. And so in this section, together with the TensorFlow datasets which we've seen already, we are going to see how to implement an efficient training pipeline with TensorFlow. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. In the previous sections, we've been working with TensorFlow datasets. In this session, we'll see how to convert our TensorFlow dataset into a TensorFlow record, and then get this TensorFlow record and convert it back to TensorFlow datasets to be used for training. Now, the very first question you ask yourself is, given that we've already carried out this training process successfully without any problems, why do we need to work with TensorFlow records? Now, there are two major problems TensorFlow records come to solve, or there are two advantages of working with TensorFlow records. The very first one is the fact that you can now store your data more efficiently. Now, notice that every time you have to create this data, you're creating this data from this data set which we've loaded here, which is made of little files of, like, say, a few kilobytes. Let's open this up so you could see it for yourself. We have this here. Let's take this one, open this folder, and then we'll see the size of this. So you can see the size is about 17.26 kilobytes. Now, the fact that we have to deal with these kinds of files means that we are not going to always have to load this data very efficiently. Now, it's true working with the TensorFlow datasets brings in some efficiency, but what if we store this data in a very efficient manner? That is, instead of storing, let's say, for example, 17 kilobytes files like this, what if we just store, say, 10 megabyte files, or say 100 megabyte files? So every time we want to read from a file, we don't have to read from many of these kinds of files, but from a single file like this one. Then another good thing with having to work with TensorFlow records, which is stored in this kind of form, is that this time around you could carry out the pre-processing before storing the data. So you could augment your data. So we have augmented data, which is now stored as TensorFlow records. So instead of having the images and then getting here, and each and every time you have to carry out the augmentation or some pre-processing before training, you store the data which has been augmented already. So suppose you have your initial data. So you have your initial data here. It passes through some pre-processing. And then let's change this color. So here we have the data, and then here we have the pre-processing. And then from the pre-processing, we have the augmented data. So after this, the data has been augmented. What we do is, instead of having to go through this each and every time, what we do is we go through this once, and we store our data in this augmented form, such that the next time we want to train our model, all we need to do is just make use of this augmented data right here. Apart from this, it should be noted that sometimes we have models, or we have sections of a model. Let's draw it this way. Let's suppose that this is our model here. So this is our model. It's made of section 1 and section 2. The section 1 is fixed, meaning that we are not going to train this part, but we're going to train only this part. This means that when you pass in data right here, when you take this data and you pass in here, the output you would have here is going to be the same each and every time, given that this here is fixed. The weights here are fixed. So what we could do is, instead of storing the data, we're going to store these outputs, which we could call embeddings. So instead of storing the data, we store this embeddings here, such that we now make use of the embeddings directly and train our model, or train this part of the model which is actually trainable on this embeddings, instead of working with the data. So this time around, we see that we have data, the preprocessing, the augmentation, and then we have the embedded, or the embeddings from this data. So here we have the embeddings. So we can now store this as TensorFlow records. So you see that it gives you, or it gives us some kind of flexibility as to what we can store, and be able to retrieve the stored data and make use of it as we wish. The second major advantage of working with TensorFlow records, apart from this efficiency in storing data, is the fact that they encourage the parallelizing of reading data. Now this means that if we're having to train our model on several hosts, let's say we have 4 different hosts, or say we have 4 different machines on which we're training our data like this, and we have our data set right here, what we could do is we could create shards of our TensorFlow record data. So here, for example, let's suppose that this is our data set, our complete data set. We could break this up into several parts. So let's say we break this up such that each host takes care of 2. So we have 1 2 1 2 1 2 1. Let's add another part here. So each of this takes care of this. So this host here trains on this data, this other one trains on this other one trains on this one trains on this. Now, as a rule of thumb, it's generally advisable to make sure that each host has about 10 of these packs of 10 to 100 megabytes of our data set. So that said, if we have a 10 gigabyte data set, like suppose that all this now is 10 gigabyte, let's take this off. We have a 10 gigabyte data set. Let's write this in here. So we have your 10 gigabyte data set. What we want to do is have here, that is each and every host taking care of at least 10 packs of our TensorFlow, of our TensorFlow record which we've created. So let's take this off. It's no longer 2. We have to create 10 packs or 10 shards of our TensorFlow records and allocate that to each and every host we have here. Now that said, given that we have 4 hosts, then we will have 4 times 10 shards to create. So we'll break this 10 gigabyte data set up into 40 different parts. So we have 40 different packs or shards of our TensorFlow data set, or rather of our TensorFlow record right here, and then each and every one of them will be approximately 250 megabytes. Since 10 gigabytes, that's, if we convert this to megabytes, we would have 10,000. We suppose that 1,000 megabytes equal a gigabyte, so we have here 10,000 megabytes divided by 40, which will give us 250 megabytes per shard or per pack that we've created here, per split of our TensorFlow records. And so this will lead to some reasonable gains, because we now can train our model on this parallelized data, and then we could also prefetch huge chunks of our data set, to be precise 250 megabytes, such that once the model is ready, the model just feeds on this data which has already been prefetched. Now you could check out the previous sessions where we talk about prefetching under TensorFlow datasets. That said, what we actually store in this TensorFlow records are this protocol buffers. And the way TensorFlow manages this is by making use of this TensorFlow example class, which is defined here. Let's check this out here. TensorFlow example, which is defined here as a standard proto storing data for training and inference. And so if you have to convert your data into this into the proto files, you would have to make use of this TensorFlow example class, and then you would have to understand this representation right here. And so in our case, where we're dealing with an image and its corresponding label, let's say we have the image of this person smiling, we have the label 1, so we have this image and the person's corresponding label. We would have to convert this data into this format before creating our TensorFlow records. Now here we have this dictionary. As I said here, it contains a key value store, example features, where each key, which is a string, maps to a feature. Now note that here we have this feature with S and here without S. So we have this features, and each and every one of them is a feature. So we could click here, you could click here and you see this feature. You could check out the documentation, and we have this content. Let's take this off. The content list can be one of the three types: a byte list, generally this is information, a float list, or an int64 list. So you would pick your feature depending on the kind of data you're having. Now here you have this features, which is like a combination of these different features here. So you have here the int list, you have the float feature, the float list, the byte list, and then here you create the features from these different features here. So from each, because this is a feature, this one here, this one here is a feature. Let's take this off. This one here is a feature, this is a feature, and this is a feature. This has been defined already here. So you can see int feature is of type feature, there is it. Float feature, the same, there is it. Bytes feature, the same, that is it. Now all this combined forms features, which is of type features. See the difference? You have this and this without the S. Obviously it's a singular and this plural. So that said, if we want to create our TensorFlow records, I want to convert our data set to TensorFlow records, we have to take into consideration this formatting of our data. So we get back to the code, and then we'll add these two imports here. Here we have this TensorFlow train. We import byte list, float list, and int64 list. So these are the types of our feature. And then we have from TensorFlow train again, we import example, we import features, and we import feature. So with that, let's run the cell. We get back to our code. We have your TensorFlow records. Now what we'll start by doing is unbatching our data. So we'll start by unbatching our data. Note that to run this, we've taken off this prefetching, as we will not need this. We'll just take our data as it is. So we have our trained data set, which has been augmented. You could carry out any pre-processing you want before storing this data, and then the validation data remains validation. So we have that val data set there. Then from here, we've run the cells already. From here, we'll go ahead and unbatch this data. There we go. We have training data set. We run this, we have this here. Then we do the same for the validation. So here we have validation data set and validation data set unbatched. There we go. We have that. You could see for yourself. Training data set. Training data set. You see it's gonna be unbatched. So you have your unbatched data set. Notice that the batch dimension is taken off. Could simply have this for the validation. There we go. Validation. You run that. See that taken off too. And then we get back to this documentation. Recall that before creating the TensorFlow record, we need to put our data in a certain format. More specifically, we need to create proto files, and the way we do this is by making use of TensorFlow example. And then to create this TensorFlow example, we have these features which we need to combine to create this TensorFlow examples. And in this documentation here, we have all that is needed to create this. So here you see, for example, this example here, we could copy this out simply, and then we paste this right here, so you could see the int, the float, the bytes. But since we are not going to use the floats here, we could take this off. We're not going to use this float feature. What we're interested in is the byte feature, because recall we have the image and we have the label. So we have the image of the person happy, and then we have the label 1. So this label will be this int feature, and the image will be the bytes feature. So let's go ahead and get this done. We have here, let's put this first. So here we have our bytes, and then we have our int. Now we're going to create an example from here. You can see clearly we've imported this already, so we just have that. Even here we could have this features. There we go. Here we have byte list. See, here we have feature. Here we have feature. Here we have int64 list, feature of type int64 list, and that should be it. So we have all this here. We take this off. We don't need that. So here we have, we'll change this name. We'll call this image. We'll call this image or images, and then we'll call this labels. So that's it. Okay, so we have this here. Let's get back. That's fine. We have that. The bytes, that's the images, and we have the labels. Now, once we have this, the next thing to do is to put in the correct values in here. So instead of having this here, we'll take this off, and then here we're gonna create a method which we'll call create example. Call this method create example. It's going to take our image and also the label. So it takes in the image and the label, and then what it returns is our serialized example. So we've had this example which we've created, and this is our serialized example. So we call the serialized to string method right here. Now that said, instead of this here, we'll take in our image, and then instead of this here, we'll take in our label. So that should be fine. We now run this, and the next thing we'll do is define the number of charts. Here we have 10 charts, and then the path. So here we'll call this TensorFlow records. Let's create this new folder here, TF records. That's okay. TF records, that's fine. And then we will have the charts with your specific number. So here we have the chart, or basically we have this name. Let's have here file name, and then here's the extension .tf record. Okay, so that's it. And then we can run this, and then the next thing we want to do is to get back to the documentation, tf.io, and then we get to this tf record writer, where we are going to see how to write in a tf record file. So we have this here. Here's a simple definition, arguments, specify the path, and here's a use this example. So we have here write the records to a file. So let's copy this simply, and then we paste this here. So we have with this tf record writer, we specify the path. Here our path is going to be this path. We have that path, and then as file writer, we're going to write our information in that. Now we want our file to get those different names. So here we have path.format, and then we'll specify a given chart, so a given part of our data. So let's get back here. Recall that when we create our TensorFlow record, we could create this as a block like this, and then we'll later on shard this, break it up into different parts. So here exactly we have 10 shards, so we'll break this up into this 10 different parts. 1 2 3 4 5 6 7 8 9 10. Okay, so there we go, we have this 10 different shards, and then we want each shard to have a different file name. And that's why if you look at this here, you see we have this formatting such that we pass in a given shard number in here. So we have the shard number. So that's it. And what we'll do now is for each shard that's out of this 10 shards here, for shard number in range number of shards, that's number of shards we specify here. Our number of shards 10, so it's basically for shard number in 10. So we are going to go through, we're going to loop through this, and we are going to create a file for each shard. So we're breaking up here. So for each and every one of this, we're going to create a file, this one a file, this a file, and so on and so forth. So let's take this off. There we go. Now getting back here, once we have had this in place, or once we've set this up, now recall that we had created this create example method right here. And if you notice, you'll find that in this here, we are actually, or this example is kind of like doing the exact same thing with this create example, where we have these different features which are created, and then at the end we have this serialized to string method which is called. So you could see here these different features, you see these features, and then they all combine to form the example and then serialization. So this means that all we need to do here is pass in, we have here, instead of this we have create example, and then we'll be passing in the image and the label. Now we'll take this off here, we do not need this, basically we don't need that, and then we'll go for image and label in our data set, in our TensorFlow data set. Let's get back up. What we're doing with now is our training data set. So for this, in our training data set, that's it, we're gonna write this. So we're gonna have to write this image and this label in our file we'll be creating. So in this our TensorFlow record file. Now given that we have to write a given shard and not just the full data set, here we'll change this to sharded data set, and then let's have this here. We have our sharded data set, which is going to be equal, we have that, our training data set, and then we'll shard. So you could get to the definition, or you could get to the TensorFlow data. Let's scroll this TensorFlow data set. Here you could have this, or you could find the shard method right here. Let's scroll down and we click here. You see we have, let's click on shard. Okay, so you see here we have the definition, takes the number of shards, and then it takes the specific index. So here we have 10 shards, and then for each index we're going to pass in the value here dynamically. So here you see that this creates different packs or parts of our data set. So here we have each pack which is going to be created. So we specify the number of shards, there we go, and then we specify the shard number. So that's all we need to create a part of our data set. So that's it. Once we have this, let's now run this and see what we get. We get in this error for sharded number. Run that again. What do we get? This but expected one of type byte. So what we pass in here is tensor, but we expected a byte. Now the next question is, how do we convert these tensors to bytes? So we do a quick Google search here, convert image to bytes in TensorFlow. There we go. We have decode image, but in fact what we'll be using to convert this image into bytes is this encode JPEG right here. So we haven't JPEG images, so we could use this here. Using it is quite simple. we'll just simply pass in the image, and then we'll consider all this to be default values. So here we have encode JPEG, and then we're gonna create this encoder method here, encode image, takes in the image and the label. And then what we have here is that we're gonna start by getting the image. We'll say image is gonna be the encoded version. So we have tf.io.encode JPEG. That's it. We pass in the image, and then we're gonna return the image and the label. So once we have this, let's add this code cell. Let's run this, and then we're gonna create a new encoded data set. Encoded data set equal this. We have training data set. There we go. We're gonna map encode image. That's it. So that each and every time we want to pass this into this file writer, we're gonna make sure that we have this in the form of bytes, so that it matches up with this here, with this feature, which is defined in our create example method right here. So we need to match this up. So that's set. Let's get back. We have encoded data set. Take this off. We have encoded data set. We told that this image has type float32 that doesn't match expected type of unsigned int 8. So what we need to do here is we need to convert our image first into this unsigned int. So we have here, now to get a solution, we'll get into tf image, convert image d type, so that we could convert, let's actually convert, let's get to C, convert image d type. So as we were saying, we could actually convert our float32 to the unsigned int. So here, all we need to do, as you could see here, you see you have the tensor, and then you have the d type specified. So that said, let's copy this, and we have that. Anyway, we're going to take the default value for the saturation. So let's get back here, and then at the level of this, or before the encoding, we're going to convert that. So here we have image equal that, and then we pass in the image here. So we have tf.unsigned int 8 int 8, and close that. So that's it. That's set. We can now, let's run this and run this again, so we could see our encoded data set. See, that works fine now. So we have our encoded data set, and then in here, instead of having this, we'll call this encoded data set. So we have encoded data set, and then we'll run this and see what we get. Value must be iterable, so we must convert this into an iterable data set. So to do this, we just have here as numpy iterator. We have as numpy iterator. We run that again. We are getting here 255 has type int, but expected 1 of bytes. This error is coming from our create example method. So let's get back to create example. Everything looks fine, but here we should have a list. So let's have this here. There we go. And run this again, and that's it. The creation of the different files now are complete. You could click open here, and you see we have all this 10 different charts. At this point, what we could do is we could save these files in the drive such that we could use it next time for training. So let's go ahead and see how we could make use of this for our training process. Now what we want to do here is to convert this back to a TensorFlow data set. So we had our TensorFlow data set, we converted it into a TensorFlow record. Like we see here, we converted this into some different TensorFlow record files, and now we want to reconvert this into our TensorFlow data set. Now to get this reconstructed data set, we are going to pass the different file names in this TF record data set right here. So what we'll have here is this list made of all these different file names right here. So this list, in essence, let's call it L, will be our path, which we'll format, and then we'll pass in this variable p. For p in range the number of shards. For p in range number of shards, let's print out this L. Run that, and we get this list, which is made of all the different files here. So that said, what we're gonna have here is we're gonna copy this. We're gonna copy this here, and then simply replace this list with it. So we have this list now. Let's have this. We have this list now, and then we run this and get our reconstructed data set. But then we need to parse this TF record data set such that we could get our original data, which was in the form of the image and the label, where the image was an array and the label was some integer. And so with that, we have here parse single example method, which we're going to make use of, which takes an example, which is basically what is contained in our reconstructed data set, takes the example and permits us to split this into the image and the label. So right here we'll have example, and then we'll get the image. We have the image. Then we'll make use of the decode JPEG method. So previously we encoded the into JPEG, or we converted into bytes. Now we're going to convert from bytes back to the unsigned integer. So here we have decode JPEG, and then we're going to pass in the example image. So we have that image. We specify number of channels to be 3. Now we have all this set. What we'll have to do is specify this feature description right here. Nonetheless, this feature description is basically what we had in this create example. And so here we have this dictionary. Let's have this images, labels, your images. We have this dictionary, which is made of the images and the labels, and then we have the data types of the images and the labels respectively. So we need to pass in this feature description in this parse single example method. Now we have that, we set to return our output. So we take example, and we have images, and then example, and we have labels. So what we're doing here is we take an input example, and then we're breaking it up into the images and to the labels, while converting these images from the bytes back to the unsigned int. So we have that. Now let's run the cell, and then here we have our parsed data set. There we go. We have parsed data set, and we have recons data set. There we go. We map this method here. So we have parse TF records, parse TF records. So we have this method. Let's run this. That's fine. And then let's see what is contained in our parsed data set. So let's take a single value and then print this out. Let's run that. We're getting this error for I in this. Let's run that, and there we go. As you can see, we have our input and then our output label right here. Now the next thing we could do is specify the batch size. So let's have this batch size here. We have our batch configuration, and then batch size. That's fine. And then we could do some prefetching. So let's carry out the prefetching. Let's just do auto tune, and then run this again. There we go. Now we should have 32 elements. Let's look at our batch, our parsed data set. Looks fine. You see, we have this 4 different dimensions, and then we have our output here. So that's it. We now have our parsed data set, and we're ready to train. So as we've said already, it's important for you to save this in some location, say for example in the drive, such that the next time when you want to do training, all you need to do is start from here. So all you need to do is to reconstruct this. So you just come and reconstruct this data set, you will parse it, and then you're good to go with this parsed data set right here. So you no longer have to load all those images from memory and all of that. Now before we move on, you should also note that while encoding the image, or while encoding the data, that's the image and the label, what we could also do is take the argmax of the label. So if you have a label, so let's suppose we have an input image like this, and then you have an output label, say 0 1 0. Instead of considering the labels to be this, we could take the position with the highest value. So this is 0 1 2, so it turns to 1. Now if we have 0 0 1, then after getting the argmax, in this case it's going to be 2, because here we have 0 position, or first position, second position, and this is the one with the highest value. So this is another way of encoding our labels, and that's what we are going to do. So we will take this and rerun again and create our data set, or create our TensorFlow records, and we're still going to run this cells again. So let's rerun this, and we have our parse data, which you could see here. You see now it's different from what we had before. So now we have the image, or we have the images, and then we have their labels. Then we could go ahead and run the model. We have the loss function defined. Now the loss function is a sparse categorical cross entropy, and this is simply because instead of the one hot notation, that is, instead of representing our outputs like this, for example, we converting them into this single integer. So like this one, for example, would be 2. If we had 1 0 0, then this will be 0. If we have 0 1 0, then this will be 1. So we've seen already that when we have this this kinds of outputs, then we use the sparse categorical cross entropy. And so that's it. We have the sparse accuracy, categorical accuracy. And now let's go ahead and start with the training. So there we go. You can see that training has begun, and we're training as we usually do. So that's it for this section on TensorFlow records. See you in the next section.